Hello everyone, and welcome to our presentation exploring determinants of longevity of biomedical databases. My name is Joseph Finkelstein, and I and my co-authors are members of the Center for Biomedical and Population Health Informatics at Icahn School of Medicine at Mount Sinai in New York. During the recent decades, the scientific community witnessed an explosive proliferation of biomedical databases. Many of these databases became indispensable resources that greatly catalyzed knowledge discovery and predictive analytics. To promote effective use of big data in biomedical research, the guiding principles of data findability, accessibility, interoperability, and reusability have been introduced. In extension of these uh, principles, a common framework for best practices in digital preservation has been developed, which includes transparency, responsibility, user focus, sustainability, and technology. Design, implementation, and maintenance of biomedical databases in compliance with the fair and trust principles may be a time-consuming and costly endeavor which requires continuous allocation of significant resources. A recent longevity analysis of over 300 biological databases demonstrated that after a period of 18 years, 77% of the databases were abandoned. Thus, it's important to prioritize allocation of resources and efforts into databases with potentially higher longevity and long-lasting impact. However, determinants of longevity of biomedical databases have not been studied systematically. The aim of our study is to identify potential predictors of biomedical databases longevity. To analyze longevity of medical databases, we constructed an analytical data set, which was based on a highly cited, well-regarded journal devoted to biological databases and their curation. Use of a single journal allowed us to avoid bias resulting from varying journal impact factors. To curate the analytical dataset, we collected all publication index in the database journal from 2009 to 2016. Citation information was retrieved from PubMed, including citations from 2009 to 2020. The H-index for the first and last author article was obtained from Google Scholar. The last author's institution ranking was retrieved from two sources, Nature Index institution outputs and the Scrimago institution ranking for university rankings. Databases were classified based on their current accessibility through the links provided in their respective publications. Databases which were not accessible or which were missing the data they were designed to contain or classified as offline. To ensure classification integrity, efforts were made to verify the database have not migrated to a different URL. Database publications were classified on whether they were presenting a novel database or a database update based on the presence of previous article or citations in the article database. Databases were also categorized on the basis of their main form of data collection, whether data collected primarily using automated means or manual data collection. Database publications were classified by funding type. The databases were divided into accessible and offline groups, and the related predictive variables were compared between two groups. Dead databases which were not accessible online via an original or proxy link were labeled offline. So overall, to assess the ability of published biomedical databases to remain maintained and accessible, we collected 518 unique published biological databases. Of these 518 databases, a surprisingly high percentage were offline. In total, 35% of these databases were not accessible. On the slide, you can see distribution of published biological databases that are classified as offline by publication year, and in certain years, the number of databases is near 50%. We analyzed characteristics of accessible and offline databases and compare them using major characteristics of the databases. We noted that the percentage of databases offline by year ranged from a high number to the smaller number, depending how long these databases were available. To further understand why over a third of published biological databases failed to be maintained for even a minimum of 5 years, we examined the effects of publication citations, author H-index, and author's institutional ranking, and studied how they affected accessibility of these databases. We found that the number of citations a database publication receives has been significantly associated with access to this database. So on this slide, you can see that for live databases, the mean number of public citation was 26 versus for offline databases, it was 12. Other significant characteristics which differed between live and dead databases were last author H-index, 48 versus 42, Nature index publication output. There was a statistically significant difference of about 100 points. They also differed in Nature index authorship share and university rank. We further compared databases based on how they were published and how data were collected and how they were funded. We found that there was a statistically significant difference between the databases for which our index article was a continuation of previous publication versus newly published databases. We didn't find a significant difference in initial analysis based on data collection type, whether it's automated or manual curation. And we find a slight difference in funding types between live and dead databases. We also wanted to understand which particular characteristics are significant drivers of database longevity, accounting for potential interaction between these characteristics. To further understand what characteristics affect database accessibility, we included specific characteristics of databases as well as characteristics of their authors. In order to measure how well the combination of this variable is able to predict database accessibility, PubMed citations, first author H index, last author H index, Nature index publication output, and authorship share, Scrimago University rank, database publication type, data collection type, and funding type were used in a logistic regression with accessible status as primary dependent variable. Each database was treated as unit of analysis and assumed independent from other databases. We found that three particular factors were significantly associated with increased longevity of databases. These include a number of PubMed citations, Nature index authorship share, and database publication type, with renewal publication being a significant driver of longevity. The results showed that with these parameters, we were able to effectively predict database accessibility with 78% accuracy. We analyzed overall characteristics of 518 publicly available online databases. As of 2020, 35% of these databases were not accessible, indicating significant attrition of biomedical databases over time, which is in concordance with previously reported data. Significant difference were found in publication frequency, in number of follow-up articles, institutional characteristics, and author citation index. Our model, which accounted for all potential covariates, demonstrated sufficient accuracy of predicting database accessibility with C-statistic of 78%. Our pilot study was restricted to databases published in a single peer-reviewed journal and included analysis of a limited number of database characteristics, which is a limitation. In the future, we planned to account for temporal trends, compliance with fair and trust policies, database size, functionality, and subject area, and to address it in more comprehensive analysis of more diverse and larger data set. Recently introduced guidelines for improved data availability and reusability, combined with comprehensive set of approaches to enhance reliability and transparency, are likely to facilitate meaningful data sharing and storage. Intelligent integrative informatics approaches, utilizing cross-linked biomedical ontologies, common data models, and core outcome sets will promote data harmonization and longevity of evolving biomedical databases. Application of appropriate data exchange standards with domain relevant content standards combined with accessible rich metadata based on applicable terminologies will catalyze effective and sustainable data sharing in the future. In conclusion, a significant number of publicly available biomedical databases became abandoned over the time. Development of biomedical databases with higher longevity and potential long-lasting impact may optimize resource and effort allocation. Future studies of biomedical database longevity should include broader spectrum of diverse databases from multiple sources and expand number of potential characteristics which may affect database survival. Thank you very much for your attention.